Hi everyone, I am just continuing the previous classification of signals. So in this video I am going to explain two more classifications like causal and non-causal signals, after that even and odd signals. So what do you mean by a causal signal? Causal signal means the signal that is existed only for t greater than or equal to 0. So the signal is existed only for t greater than or equal to 0. That means x of t is equal to 0 for all t less than 0. Okay, that means only for positive time axis the signal is present and there is no signal for the negative time axis. So example, so this is t and x of t. So any signal that is present on the right sided part of the x-axis and y-axis is nothing but a causal signal. Okay, hope you understand. So causal signal means the signal which is existed only for the positive time axis. There is no signal present on the negative time axis. And now coming to the hidden part of the causal and non-causal classifications, which is anti-causal signal. Generally anti-causal signal is also there, but which is not written in the heading. Okay, so with the classification given like causal and non-causal, but anti-causal signal is also there. Anti-causal means which is opposite to the causal signals. Simply it is nothing but opposite to the causal signal. Opposite to the causal signal. So opposite to the causal signal means what? The signal is existed only for the negative time axis. In the anti-causal signal, the signal is existed only for the negative time axis and there is no signal present on the positive time axis. So the signal present for t less than or equal to 0 and no signal for t greater than 0. So simply you can draw the example like this. Any signal on the left handed side. So this is x of t and this is minus t. Okay, so this is anti-causal signal. Right side means causal, left side means anti-causal. Now coming to the non-causal signal. Non-causal. What do you mean by non-causal? Non-causal is nothing but which is existed for both the time axis, positive and as well as negative. Okay, so the non-causal signal is existed for both positive and negative time axis. Okay, that means the signal is existed for both the time axis, means this is non-causal signal. Okay, so non-causal signal is nothing but x of t is not equal to 0 for all t. Okay, this is what a non-causal signal. It will never be 0 for any sided part, whether it is a positive side or negative side. So that is non-causal signal. Don't confuse many definitions in some textbooks. Only causal and non-causal is mentioned. Anti-causal signal sometimes referred to as a non-causal signal, but there is a difference. Okay, if you go and Google it, then you can understand the difference among these three. Okay, so causal signal existed for positive sided signal, anti-causal signal existed for negative sided signal, and non-causal signal is existed for both the positive and as well as negative. Now coming to the last classification, even and odd signals. Even and odd signals. So even signal also known as a symmetric signal, and odd signal also known as a symmetric signal or non-symmetric signals. Okay. So first let us see the even signal. A continuous time signal. See, one more thing I want to say, whatever the classification and examples I have taken for continuous time signals also valid for discrete time signals, because the classifications are for both the continuous and discrete time signals. Okay, so a continuous time signal x of t is said to be an and even signal if it satisfies the condition the condition so the condition is x of t must be equal to x of minus t for all t. What do you mean by x of minus t? X of minus t is the folded signal, vertically folded signal. Okay, and for discrete time signals, x of n is equal to x of minus n. X of t must be equal to x of minus n. This is also for all n. Okay, so we can say even signals are symmetrical about the vertical axis about the vertical axis. That's why they are also called symmetric signals. Okay, so even signals are symmetrical signals about the vertical axis. So let us take an example of the even signal so that you can understand. I am taking one example like a signal has a shape like this. This is 0, this is x of t, and this is t. Okay, so when you fold this signal vertically, that means this part will be here and this part should be here. Okay, just vertically fold this, then how it appears, this is t and this will be now minus t. Minus t means I'm just folding the signal vertically. So vertically along this axis, vertical axis, I'm just folding the signal. What happens? Same signal is appeared. So here what happens? X of t is equal to x of minus t. So you can simply call this signal as a symmetric signal or nothing but an even signal. Okay, and I am drawing another example. So a sinusoidal signal, shifted sinusoidal signal. Okay, now take this signal x of t and this is t. Okay, now fold this signal vertically along the y-axis. What happens? You will get x of minus t, but there is no change in the shape of the signal. You will get the same signal. Okay, so this is x of minus t. So such type of signals are the examples of the even signal. Okay, now coming to the odd signals are anti-symmetric signals. Anti-symmetric signals. So a continuous time signal, a continuous time signals are said to be odd signals if they satisfy so the condition is x of minus t must be equal to minus x of t. X of minus t must be equal to minus x of t. Okay, so then it is an odd signal for all t. This suppose for discrete time signals you can redefine this as x of minus n must be equal to minus x of n. Okay, so then such signals are known as antisymmetric or asymmetric signals. So example for such signals is this is x of t. A signal is given like this. See, first I am just drawing x of minus t for your understanding. X of minus t. What I said for drawing x of minus t, fold this signal. So fold this signal vertically. So what happens? Like this it appears and like this it appears. Okay, so just I have folded this vertically. Now apply negative amplitude. Negative amplitude means fold this horizontally along the time axis. Fold it x of minus t and minus. Okay, so x of minus t, just from this equation we can write x of minus t as minus x of minus t. Then you will get the original input signal back. Okay, so this signal and this signal both are same. If you understand, both the signals are same. So x of minus t is equal to minus x of t. Otherwise you can also write it as x of t is equal to minus x of minus t. Okay, just for your understanding I am taking one more example for better understanding. See here, so this is t, this is x of t. See here, I am taking a signal like this. Okay, this is a signal, this is 0. Now first let us draw x of minus t. X of minus t. X of minus t means what? Folding vertically. Vertically folding. So vertically folding means this part appears here and this part appears on the right side. So here, here and here. Okay. So folded vertically. Now draw the signal t x of minus t with negative amplitude. So what happens? Now I am just folding horizontally. So this part goes upside and this part goes downside. Okay. So now and observe the first and last figures, both are same. Okay. So x of t must be equal to minus x of minus t. Then it is an odd signal. Okay. So these are the classifications of signals. Thank you.